Welcome to Mrs. Z's Chemistry. In this video, we will discuss isotopes and chemical formulas. This is called a mass spectrometer. It analyzes samples of substances and produces a mass spectrum, which is this graph on the right, with peaks showing the different isotopes. On the x-axis is the mass-to-charge ratio. The charge is always a +1, so we can consider the x-axis to be just the mass. The y-axis is the relative abundance of each isotope. Here are some sample questions you could be asked about a mass spectrum. In the graphs you'd be given on a quiz or a test, each peak won't be labeled with the element symbol like it is here. Remember that to find the average atomic mass, we calculate a weighted average of all of the isotopes. So for this first question, when it says what element is represented on this graph, we look at the masses on the x-axis, and looking at the relative abundance, we can see that it is weighted closer to 90. An exact average would be around 93. But because we're not trying to find an exact average, we're looking for a weighted average. We know that the weighted average will be somewhere above 90, but probably less than 92. If you look at the periodic table, we can find some masses here that are around 88 to 92. Yttrium, with a average mass of 88.91, is not possible from this graph because we can't have a weighted average that's less than the smallest or lowest isotope. Looking at zirconium, we can see that its mass is 91.22, and that is a good estimate or a good guess for this graph. Niobium, though, let's look at that. It has an average mass of 92.9, and that's almost the 93 that we determined should not be the correct answer because we're not looking for an exact average, but we're looking for a weighted average. So that's how we can figure out that this graph is for zirconium. How many isotopes of the element is this graph showing? For that question, you just count all of the peaks. 1, 2, 3, 4, and 5. Which isotope is the most abundant isotope? Well, that would be the tallest peak. So that would be the zirconium 90 is the most abundant isotope. For this last question, it's very similar to the first question, where we need to consider the weighted average and find that the average atomic mass is closest to 91. Now we're going to learn about chemical formulas. A molecular formula is a representation of a molecule that uses chemical symbols to indicate the types of atoms, followed by subscripts to show the number of atoms of each type in the molecule. This molecular formula here, CH4, says that we have 1 carbon and 4 hydrogens in the molecule. This next picture is a structural formula showing which atoms are connected to which other atoms in the molecule. We can see that the 4 hydrogens are connected to carbon. We can also see that none of the hydrogens are connected to each other. The next two pictures are 3D models of the structural formulas. We can see that the molecule is not actually a flat 2D shape that looks like a plus or a cross sign. Instead, it has more of a tetrahedral shape as these 3D molecules are showing. We can use these different types of models of the molecules to emphasize which part of the molecule we want to talk about or learn about. So you'll commonly see all 3 of these different types in different textbooks or if you're reading online about chemistry. Some elements exist as a molecule made up of 2 or more of the same type of element chemically bonded together. These are called diatomic molecules. Di is a prefix for 2, and atomic comes from atom, so we have 2 atoms in the molecule. All 7 of these elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, exist as 2 of themselves bonded together. None of them exist as one single atom floating around in nature. These 7 elements are on the back of your periodic table, right here. So you do not need to memorize all 7 of these elements. This is a mnemonic to remember them in case you later take a class like AP Chemistry or a college level course where you need to memorize these 7. Hofbrinkel, that's hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Let's talk about the difference between coefficients and subscripts. If you have just one single hydrogen atom, one single hydrogen element symbol, that means you have one single hydrogen atom. If you have a coefficient of 2 out in front of the hydrogen symbol, then that means you have 2 individual single hydrogen atoms. If you have a subscript 2 after the hydrogen element symbol, then that means you have one hydrogen molecule where 2 atoms are chemically bonded together. If you have both the coefficient and the subscript, that means you have 2 H2 molecules. There's a subtle difference between molecules and compounds. For a molecule, that requires 2 or more atoms in a unit. All 4 of these are molecules. In order to be a compound, though, you have to have 2 or more different atoms in a unit. So these last 3 are compounds. One way to put it is that all compounds are molecules, but not all molecules are compounds. We've already discussed molecular formulas. The molecular formula for this molecule here is C6H6. We have 6 carbons and 6 hydrogens in this molecule, which happens to be called benzene. The empirical formula is the simplest whole number ratio of the number of atoms in the compound. So if we were to reduce this molecular formula down as much as possible, we would have just 1 carbon and 1 hydrogen. We don't use the number 1 for subscripts. You just write 1C, 1H. There isn't actually a real molecule with only 1 carbon and 1 hydrogen chemically bonded together, but this is just showing the simplest whole number ratio, the empirical formula of the molecular formula, which is the actual chemical formula. Let's try a practice problem. What is the empirical formula of acetic acid, which has this molecular formula and the following structural formula? C2H4O2. If we were to reduce the numbers 2 to 4 to 2 down as much as possible and include the element symbols, we would write the empirical formula like this: CH2O. Acetic acid is vinegar. Here are 2 more example problems. Pause to see if you can work these out before I show you the answers. The molecular formula for glucose is C6H12O6, and the empirical formula is CH2O. The molecular formula for metallaldehyde is C8H16O4, and its empirical formula is C2H4O. There are certain chemical substances that have the same molecular formulas, but 2 completely different structures. And they are, in fact, because of those different structures, different chemical substances. So we've already seen acetic acid with its molecular formula C2H4O2 and its structural formula. Methylformate is another substance that has the same molecular formula C2H4O2, but it has a completely different structure. The different structure causes it to react differently with different substances, making this a completely different substance.